Okay, let's start practicing our clap. Great, thank you very much, Ellen. And today I'm so excited to introduce the speaker to you today. One, not only is she a fantastic researcher and collaborator, the subject of her research is super hot. PFAS is hot in the news. One of the big topics across not only our country, but across in the world. There's a new movie out, and Andrew alerted us to this. So it's one of the reasons we picked this day for our visit was because the movie Black Waters is coming out. Dark Waters, sorry, Dark Waters is coming out. So we were trying to do like a go to the movie event, but we couldn't get tickets. There's another movie on Amazon Prime or Netflix called The Devil We Know. It's also very good, investigation on the PFAS story. And that dives more into the Little Hocking area in West Virginia and Parkersburg. So let me introduce to you Dr. Jane Hoppin. She has an illustrious career. She started, let's talk back to her bachelor's in environmental toxicology. So she is primed to do this research study. Environmental tox from University of California, Davis. Her master's and then her doctorate was also at the same university, Harvard School of Public Health. She did her degrees in environmental health and in epidemiology. She then did a postdoc at Harvard briefly, but then went on to Emory University at the Rollins School of Public Health as faculty before joining NIEHS. And she stayed with the National Institute of Environmental Sciences for quite some time. And you think as a nice comfy job, working with the feds, you don't have the push and rush for research grants. But you can see with her training, I think she got a little bit antsy and I don't want to say bored, but like ready to go for her own research agenda. So she landed a faculty position at North Carolina State. And right after she got there, I don't know how long she can tell you her story, GenX hit the scene. Wilmington in North Carolina, there's a community issue, and Jane was ready. She attacked it with her full force, vigor, and knowledge of the expertise that she had accumulated. And today we have the privilege of hearing her and her story and how she's partnered with the community to study this incredible topic. So without further ado, let's welcome Jane Hoppin. I think science should get as much cred as the rock stars. So let's do it one more time for Jane Hoppin.
You know, you can always tell the community engagement people. They have you standing up and they have you talking. So I'm happy to be here today and talk about my work with the GenX Exposure Study. I only now talk to Sarah about how long my talk should be. So it might be a little long, but we can cut to the chase if we need to. And during this talk, you can figure out who's going to play me when we make the GenX movie. It's been a really important question in my office now. So not Julie Roberts, because she doesn't look like Aaron Brockovich either. So, okay, so back to the real world. So I want to talk about our project, and it's really responding to this issue of GenX, which is a novel PFAS. So for those of you not schooled in this alphabet soup of PFAS, like I tested this. Why did I break it now? I think it was Aaron.
It might have been.
Okay, so, all right, well, just pretend we move forward. And so in December of 2016, one of my colleagues, Detlef Knappe, published a paper with Mark Stringer and Andy Lindstrom at EPA that showed that GenX and other novel PFAS were found in the Cape Fear River, which is the water supply for Wilmington, a city of about 250,000 people, and that standard water treatment did not remove this chemical. And then after a lot of hard work on Detlef trying to get somebody interested in it, it hit the news in June of 2017 when everybody in Wilmington woke up to find out they had been drinking Teflon for 40 years. And so that's how we got involved. Okay, now I have to send it the right way. So it hit the papers. This is the original article. And then in June of 2017, it's the first time it's in the newspaper, and then there was public meetings and runs on bottled water and sampling of wells. And I think this is the chemical plant. And the chemical plant is almost 100 miles upstream. And so it has a permit. They had a permit from the Department of Environmental Quality to discharge wastewater. Apparently no one had read it for the past 20 years. So the community was concerned, to say the least. And so there were a few community forums, including one that our P30 Center hosted, to ask the scientists about what people wanted to know. And so there was a lot of public health concern and a lot of politics. I mean, Aaron Brockovich did show up, actually. So we're focusing on the Cape Fear watershed, which is the largest watershed in North Carolina. Like Kentucky, we're a long, skinny state, and we have a lot of different watersheds. And the Cape Fear River in its entirety provides water to over 1.5 million people. And so the town of Wilmington, which doesn't work on my pointer, but it's at the mouth of the Cape Fear. And so they drink everything that gets discharged into the river. And I have a slide that shows where the chemical plant is. And so we got involved. So my career has focused on pesticide health effects mainly. And so there's a lot of language being thrown around. And one of the language, the terms was emerging contaminants. What is an emerging contaminant? And, you know, if you think of something emerges, it pops out of the ground and you've never seen it before. And that is not true. Usually they're not new chemicals, but rather they're newly measured or newly found. So with high resolution mass spectrometry, particularly in all these untargeted modes, you can find things that you didn't know what you were looking for. And clearly they're not regulated. And emerging contaminants has a specific definition under the Clean Water Act. But usually it means that there's no exposure data. We often don't know what the chemicals are. How do people get exposed? Are they exposed in water or air? And there's no toxicology data. So how long do they stay in the body and the environment? What are the potential health effects? And no human health information. So it makes for a lot of interesting science, but kind of a panic if you're part of a community that wants answers right away. And so this is, and so you also don't know a lot of information on like production volumes or emissions to the environment. So what are PFAS? So PFAS, depending on how old you are, you might be familiar with the term PFCs. They were perfluoroalkyl chemicals, but since those included the chemicals that destroy the ozone, for a while they were called PFAS, for perfluoroalkyl acids. And now the current term is per and polyfluoroalkyl substances. So PFAS is a class of 4,000 to 5,000 chemicals that we don't know much about what they are. And the chemicals that are used in industry are used to make things that contribute to stain and water resistant products. So Teflon pans, Gore-Tex jackets, paper containers that don't leak. All those things probably have some magic property that makes the chemicals, water not go through. But the chemicals themselves are water soluble, and they're environmentally and biologically persistent. So they're characterized by many carbon-fluorine bonds, and the carbon-fluorine bond is the strongest bond out there. And then you have a chemical that has 8 carbons and at least 2 fluorines per carbon. So they don't want to break apart. They're going to persist. And so they're going to persist, which means that the treatment technologies are challenging, because how do you destroy chemicals like that? So interesting to follow. So some of the also term of art are these groups of chemicals, the legacy chemicals. So legacy are older chemicals, some that started use in the 1940s and 50s. They're also chemicals that we know more about. So we know about their environmental fate and transport, some about the toxicology and health outcomes, There's some population data because the NHANES study has been measuring PFOA and PFAS in the US population since 1999. So we know something about these chemicals and can make inferences, but the new or emerging chemicals we know very little about. Some of the chemicals are new and some of them are newly identified. So GenX is regarded that, and GenX is a byproduct of chemical production, and it's also an active ingredient. And those two terms influence how they're regulated. And the Nafion byproduct 2 is just a byproduct of production, which means there's no chemical testing on it. So this is just part of the alphabet soup of the PFAS that are used in commerce. And this paper was from 2017. And what it does is it breaks down chemicals by how much scientific publications have been around specific chemicals. So the ones at the top you can see have more papers published than some at the bottom. And in about the middle are where GenX and Adana and some of those new chemicals. And these are only chemicals in commerce, not chemicals that are waste products of production. And that becomes very important for our situation. So in 2013 through December of 2015, under the Clean Water Act, there was some national monitoring for these chemicals under what's called the unregulated contaminant monitoring rules. So we have emerging contaminants that are also unregulated contaminants. And so they sampled all the public water systems with more than 10,000 people in the United States, as well as 800 public water systems that serve fewer than 10,000 people. And so they had 6 PFAS that they included, but the detection limits were between 10 and 90 parts per trillion. So the levels are generally low. So the advisory limit for PFOA and PFOS, either independently or together in water from EPA, is 70. So ostensibly, you would see that. But if you use New Jersey's action levels of 13 or 14 parts per trillion, you would miss that because they didn't report anything that was below the limit of detection. So this is where you start to hear numbers like 6 million Americans are drinking water that contains above the advisory level for PFOA and PFAS, and that's only for PFOA and PFOS, and it's only for those public water supplies, not private wells. Okay, backwards. So as I mentioned, they're used in a lot of manufacturing process to make nonstick coatings, French fry wrappers, pizza boxes, microwave popcorn, Scotchgard, but also used in firefighting foams. If you want to put out an oil fire, you don't put water on that. So you want to use something that will knock down the fire. And these firefighting foams are really effective at that, but then they wash into surface waters and they don't go anywhere. So the two most commonly studied are PFOA, which is C8, and that's used in Gore-Tex and Teflon, and PFOS, and that's used in firefighting foams and sulfonates. And I would say that if you have a Gore-Tex jacket, don't throw it away because it goes to the landfill. But what we really want to work toward is having the processes that make these chemicals be responsible throughout the system so we're not polluting the environment to get these products that are very useful for us. And so unlike firefighting foam, which is designed to be released in the environment, we need to rethink that. But your Gore-Tex jacket, while it works, you should wear it because hypothermia, if you're in that situation, is a % risk. So if you want to think about risk managing, you need to think about that. But if you have an old Teflon pan, throw it away. Don't give it to the thrift shop. You know, like think about, are you passing on that exposure? So that's maybe my only editorial comments here. So in general, the levels of these chemicals are dropping in the United States. So this is data from the NHANES, the National Health and Nutrition Examination Survey. And they measured in almost every cycle since 1999, except for in 2001, 2002, they measured PFOS is always the most in the highest concentration, but it's also dropped the fastest. And then PFOA, PFHXS is about the same, and PFNA, which is a replacement, as you can see, is starting to bump up. And the levels are low. These are in parts per billion. So in drinking water, we talk about parts per trillion. And in biological fluids, we talk about parts per billion. So it means that there's bioconcentration that happens. Our communities try to convert their water levels to blood levels. And so it leads to some interesting conversations. Like, why do we have different units for different media? So the history of contamination that we're going to talk about today is at a DuPont facility that started making Teflon in 1980. And GenX was released at that point as a waste product. So no regulation on waste products. About 2000, they start to switch out, and GenX was produced as part of their vinyl ether product. And so when they start to make Teflon in about 2004 or 5, GenX replaces C8 or PFOA. It's actually in 2009 because of the Parkersburg consent decree. And so as part of that Parkersburg consent decree, you have to save all of your active ingredient and dispose of that appropriately as hazardous waste. If it's a byproduct of production, so the vinyl ether product, you still keep releasing it to the river. The toxicity of the chemical does not change based on how it's used. So this is one of the structures. And so one of the unique features of the fluoroethers is this oxygen group in the middle, because the older ones are all carbon backbones. And so the oxygen group in the middle is supposed to make it less environmentally persistent and have a shorter half-life. And it may have similar health consequences to some of the legacy chemicals. But it's part of this whole soup of chemicals that are found in the Cape Fear River. And so since the pointer doesn't work that far, so that you can see that there's lots of ether oxygens in the group that makes them longer, seem like they're longer than the short carbon chains, but they can, and so there's a lot of polymers that are produced in the production because they're just discharging the waste that they don't care about. So here's the sampling scheme that led to our study. So again, here's the Cape Fear River, and community A is in Pittsburgh. It's the upper part of the Cape Fear River, relatively close to Chapel Hill. Community B is Fayetteville, home of Fort Bragg, but just downriver of that is where the Keymore's Fayetteville Works plant is. And so that's the purple manufacturing site. And then C is Wilmington. And so what they did, so they found in community A, they found a lot of those different colors of PFAS. And so at this point, so these are all concentrations. So that means we have analytic standards. But you can see that community C has this big red bar, and that big red bar is GenX. And so where is that coming from? It's not upstream in either of the two communities. So where does that come from? And so then it's also part of these whole newer chemicals. And so we start to look at, now you notice that the x-axis is now peak area counts of emerging PFAS, because we're doing non-targeted analysis, which means that we're finding new chemicals. So we can see the peak, we can see how big the peak is, but we don't have a calibration curve so that we can quantify it. And so the GenX is part of that, but there's a whole other, blue and orange and red that aren't GenX that are in the water treatment plant in community C. So lots of other chemicals in addition to GenX. So what do they mean? How long have I been exposed, and what are the health effects That's pretty much what the community wanted to know. So because Wilmington is one of the wealthier communities in North Carolina, they were really successful at getting the Department of Environmental Quality to respond very quickly. And so within 3 weeks, the company had stopped discharging GenX to the Cape Fear River. And you can see that drop from about 700 parts per trillion to the newly established health goal of 140 parts per trillion within a week. And then you can see where they had another spill and they found another discharge point. And so you still see some of those, but they were really effective at reducing the exposure into the river. So what are the potential health effects of GenX? Most of the data are for the legacy chemicals. And we don't have any information on mixtures, but some data from human populations that show, and most of the studies have been cross-sectional. So or using data from stored biological samples. So most of what we know from people is from the C8 Science Panel study, which is what it's part of the movie Dark Waters, but basically it just is like turning the pages for the 10 years or so that it took to get the answers from the health study, because under the court order, they conducted a health study of about 69,000 residents who had consumed water from 5 or 6 water districts around the Parkersburg, West Virginia plant. And so what they showed was increased cholesterol. And now we see that in lots of other populations and animal studies. Ulcerative colitis, which is a pretty rare immune disease, autoimmune disease, thyroid disease, pretty common, testicular and kidney cancer, and pregnancy-induced hypertension. Because of the structure of the study, it was not good to look at highly fatal cancers because they looked at exposure, people exposed from 1950s forward, but they did the study in the early 2005, let's say. And so people who had diseases that are characterized by high fatality were probably missed. But that's the broader level and a whole population in there. We also see that increased cholesterol is pretty common. And one of the most important things, because biological markers are influenced by biology, that the fact that we can see association with cholesterol both with biomarkers of exposure, but also with measured, like modeled exposure that's not related to biology. So how much chemicals got released into the environment and predicting people's exposure that way. One thing that's interesting, and it may be an artifact of their study design, is that we haven't seen a lot of evidence of impact on cardiovascular disease outcomes that you would expect with elevated cholesterol. And so maybe that's something that we will learn later. We see hypothyroid disease in both children and adults, and reduced immune function in animals and people. And probably most important is reduced response to vaccines. And so if you think about the flu vaccine not being very efficacious, you give it to people with poor immune systems, and then you have PFAS, which minimize your response, that there may be other impacts of these chemicals, and some evidence of increased asthma. And most of it's regarded that the immune impacts are the most sensitive endpoint for these chemicals. Their cancers are of importance, lower birth weight, though when you use modeled exposure data or collect biomarkers very, very early in pregnancy, you do not see those differences. So the understanding of what's happening there, and ulcerative colitis is rare, so it will be difficult to see in other places. So we got involved in the GenX Exposure Study to answer 3 questions. Are PFAS detectable in my body? What predicts PFAS in my body? And are there health effects associated with PFAS? And when you have 3 questions, it's really easy to write your specific aims because they just align. And so we started, so community found out in June of 2017. We, the Center for Human Health and the Environment, had a community meeting in July of 2017 where we said, we're going to submit this grant. I submitted August 1st. We got funded November 1st. And then 2 weeks later, we had collected blood and urine samples from 310 people. And so we've been kind of moving at that pace since then. But we really wanted to, we didn't know anything about the half-life of GenX. So we wanted to move quickly. And we wanted to get people all sampled at the same point in time, so that if levels were coming down, that we didn't have to deal with that change going on. And so we've been reporting water data back to people. We enrolled some new people in May of 2018. We reported the blood data back to people in Wilmington about a year ago, and we were funded through the NIEHS Time Sensitive Grant Program. So this is all community-based, and we have a lot of partners. We partnered with the Cape Fear River Watch, which is part of the River Keeper program, as well as the New Hanover County Health Department. They let us take over their shop for a weekend. So we had the lab, we had the scales, we had all the people, and that was pretty awesome. And we also had partners with a Spanish language professor, so we could translate things into Spanish. Her students had like engaged training, and so they were out. We recruited people at Spanish grocery stores. It's a lot of work to do things in 2 languages. And so we have to be very conscious of like not forgetting, oh, we have to translate this into Spanish. So we collect tap water. We drew blood, collected a urine sample, administered a questionnaire. We got a lot of information on residential history as well as water consumption history. We measured height and weight. And when we partnered with the NAACP on a second blood collection of May of 2018 to recruit more African Americans, and also at that time we resampled 44 of our original people. We have 344 participants. Overall, we range in age from 6 to 86. And as you can see, we have the adults are in red, and some adults who've lived in the region less than 5 years, and others that more than half have lived there almost 20 years. And the children, I would say over half our kids have lived in the region their whole lives. So we have a lot of diversity just in exposure there. And then we also have some pretty good racial diversity as well. So what's in the water? So this is our team of graduate students, postdocs, and Riverwatch employees. So we continue to test for the chemicals that we know about or have standards for. And so when we did this work, we had 17 legacy chemicals. Oh, I see, I moved that. We had 11 legacy chemicals and 6 newly identified chemicals. 6.2 FTS has been on the border, so we move them back and forth. So, but in general, legacies have been around for a while. 6.2 FTS is related to firefighting foam. So the first thing is that the levels of GenX that we measured in people's homes, all of them were below the 140. And all these people are getting water from municipal water treatment. And so 4 of our homes were people served by the groundwater source, and they have no GenX in their water. People who are served by the Cape Fear River, there's a variability over the month that we sampled. So some have almost 100 parts per trillion, while others have non-detectable levels. On average, it's about 50 micrograms or nanograms per liter. And then, but our levels, the open circles are the levels from the water treatment plant at the same time point. So there's inherent variability because what's coming out of the plant, what's left in the river, and so, and people don't all live at the same house. So, but our samples look like what we would expect. We also found, so we found GenX, but then we found, so the red bars for PFMOAA, neophilus 2, and PFO2HXA, all of those were in the higher machine response than GenX, but we didn't have analytic standards. We're now reanalyzing these data, and so we do. So in our paper, we'll be able to report that. So it just goes to argue that there are more PFAS compounds in the water than we originally started looking for. So what about in the blood? So did we find GenX in the blood? If anybody's seen it, the answer is no. We did not find GenX in the blood. We had a method reporting of 2 parts per billion. Mostly we were much lower than that, but we had 1 of our 8 runs that did that. So one of the things is that we think the half-life of GenX might have been 30 days. And in toxicology, you regard 5 half-lives as complete elimination. So we were 5 months after they learned that GenX was in their water and the levels came down. So whether you stopped drinking water or you were drinking the water that had lower levels, that we may have missed it if the 30-day half-life was there. Because when we sampled in November, there was about 50 nanograms per liter. And then in May, it was less than 10. So also, there had been a small study for people around the plant that the North Carolina Department of Health and Human Services did, and they did not find GenX in the blood of 30 people living around the Chemours plant. And this was done by the laboratory at CDC. And so I feel like, even though we were using different methods, that it's probably unlikely to find this chemical in blood, which means that we need to think more about how we're going to model exposure, because we know that people were probably drinking 700 parts per trillion for 4 years, every day for 4 years. So, not just all the good news of no GenX, we found naphthalene byproduct 2 in almost every person. And if you look at this chemical, you can see the 2 red ether oxygens in there. I think it's 8 carbon efficient. We found this other one, and the nomenclature of these are crazy, but we had the PFO4DA and then PFO5DA in about 87. So these are byproducts of production. So no toxicity data, no nothing. So, so we also found, we looked at the legacy chemicals. And so here's the level of PFOA in the US population in 1999. And so these are box and whisker plots. So the bottom line is the 25th percentile, the middle line is the median, the 50th percentile, and the top of the box is 75th, and 95th is the top, and 5 is the bottom. So US population almost 20 years later is a lot lower than it was in 1999. And then you have Wilmington in 2017. So Wilmington in 2017 looks like the US population in 1999. This chemical contamination is probably not just due to the Chemours plant. These chemicals are also found upstream, and we don't know why. So this was like, we give this public meeting, no GenX, we see these new chemicals, and then we see this, and this is when the room gasped. And so what you can see is, this is the most striking thing to me, is that the median for Wilmington is greater than the 95th percentile for the United States. And so when you think about communicating results to communities, that's something that's like, even though these are box plots, that's a pretty compelling point. So unfortunately so. So why could there be elevated PFOA? There's PFOA in the Cape Fear River, though. If you think finding archived blood samples is difficult, finding archived water samples is almost impossible. And so there's limited data, but from 2002 forward. But there's also a calculator that Scott Bartell put together that predicts PFOA levels in blood. And so the levels of PFOA in Wilmington tap water were about 18 nanograms per liter, and that would result in about the level that we saw. So it could just be residual, that these levels over a long time, 10 to 20 years, will lead to that. And so this figure, the green is Wilmington, and the white boxes are enhanced in 2015-16. So it's not just PFOA, it's PFHXS, PFNA, PFDA, and PFOS, which has to be on another scale, and so then apparently it's other piece moved over. But particularly PFOA and PFHXS are much more elevated than the US population. So the good news, if there is any good news, is in the 44 people that we measured twice, 6 months apart, we see that naphthalene byproduct 2 average levels dropped from about 4 parts per billion to 2.5 parts per trillion. The drop of PFO4DA is much greater, and the drop of PFO5DA, which were generally lower, was still about half. So the levels of the new chemicals are coming down. And so one of the things is like, so when we go to measure these people today, we might not see these chemicals, but we know that they had these chemicals in them. So we're going to have to really spend some time thinking about how do we reconstruct exposure, and how do we think about these chemicals as a mix, because they're not independent. So not surprisingly, the levels of the legacy do not drop in 6 months, because these generally have a half-life in the order of 3 to 5 years. Though it suggested that females have a shorter half-life, and it may or may not be due to menstruation. It may also be due to different kinds of protein cycling in women. So what about the air? So because we weren't having enough fun, we wrote a supplement to our grant to look at the people who live around the plant, because that's a private well community. And so it took a while. So in July of 2017, they'd already turned off the source in Wilmington. DEQ didn't require Chemours to do any well water testing until August of 2017. And they required Chemours to go out a half a mile, like, oh, if you find something, keep going, keep going, keep going. And still to this day, people are having their wells tested and they're identifying GenX. So they haven't found the outer perimeter. So if you want to look at perimeter contamination, I think you should go big and come back in. Because some people continue to be exposed while that happens. So air seems to be the reason those wells are contaminated, and partly because the wells are downwind but upriver of the discharge to the river. So most of the wells are contaminated with the low molecular weight, so not the naphthalene byproduct 2 and the bigger chemicals. And this is the same way it happens. This is actually from Parkersburg, West Virginia, but you release it to the air and it comes to the ground and it goes into the well, or you just direct discharge. And so this is a slide I got from someone at DEQ, and I was talking to someone earlier today, and so Department of Environmental Quality is putting these maps on the website. If you know about human subjects, like, we would be shot if we were to do this. And so if you live, and that's your property, with the big red bar. Like, you can't sell your property. You have 140 parts per billion. So the light green is the chemical plant in the middle. And what you see is that, there's prevailing winds to the northeast, but that winds don't all go in the same way. And I think that's probably the 5-mile radius, but they continue to see contamination. And these are the wells. So wells aren't all the same depth as, so hard to see. So here's some rainwater sampling. And this is, so they were still releasing it to the air at that point. But you can see that 5 miles from the plant, you have 810 parts per trillion coming down in the rain. And so if you're going to contaminate a well to like 4,000 parts per trillion, you have to have a lot of those rain events to happen. So, so that's what's happened there. And so when we enrolled the people in Fayetteville, who are the best study subjects ever, we have like 100% response rate on everything we asked them to do. And so We are also getting information. We've collected dust samples in their home. We didn't get them from carpeting because carpeting is full of stain master. We got them from the linoleum. We had people wear wristbands for a week. And we collected both tap and well water samples. And we're doing a whole suite of non-targeted PFAS there and in the blood and urine. And the analyses are ongoing. But there are widespread impacts. And this slide I got from the Riverkeeper. So contaminated drinking water for over 250,000 people. Airborne pollutants impact surface water, groundwater, fish, and honey. People have measured honey with 1,000 and 4,000 parts per trillion. How does that happen? In a really bad communication effort, FDA went to a meeting in the CTEC meeting in Finland and presented some information on GenX levels in the greens of Fayetteville, North Carolina. And so the next day, because people have cameras on their phones, it already made it back to the US. So if you're going to measure things in people's neighborhood, please tell them first. But we do see that there are, and there is contamination of homegrown fruits and vegetables, and whether it's from the ground, from the water onto them or from the ground up, where work is happening on that. And we're getting samples of like preserved food, but most canning uses water, and so you want to be careful about not just sampling water in this way. So when this slide was made, there was over 763, this was 1,000 private wells, so about 4,000 people potentially impacted. And rainwater contamination is broad. So lingering questions are, how long were people exposed? When did Nafion byproduct 2 start to be released? So Nafion is an ion exchange resin that's used in phones and all sorts of magic things. A lot of these chemicals, some of these chemicals are used to like make our windshield shatterproof. I vote for that. So, we want to we don't want to throw the baby out with bathwater, but we need to be sure that we're not releasing these chemicals to the environment. So how can we estimate exposure levels to chemicals with short half-lives? And I end up using the analogy of alcohol a lot when I talk about like GenX. We can't measure your alcohol exposure from Saturday today, but we know that, moderate alcohol consumption over a long period of time has consequences. So how do we try to create those kinds of models so that we can think about what the exposure levels were? And as we start to analyze some of the health effects, we see more specificity when we look at the individual chemicals than we look at variables like how long did you live in the lower Cape Fear region. So we don't want to walk away from the chemical specificity, but some of this chemical soup, chemical mixture, we won't have good ability to look at. Are the chemicals in the air the same as the ones in the river? So clearly the air drops into the river, but the wells seem to have more of the low molecular weight ones. And the exposure sources for the most part have been controlled, at least for the new chemicals. So upriver, we have a lot of textile mills, leaking landfill, estimates of discharge to the river. So how do we capture that? And so exposure is still a mixture of chemicals. So we're going to analyze our collected samples, and are they the same between Wilmington and Fayetteville? And we're starting to look at health outcome data, particularly thyroid and cholesterol, liver function, and BMI. There's also a lot of interest in like osteoporosis with these. So there's chemicals that influence people across the life course, outcomes that are important for many things. So we have a big team, and I have a small subset. These are just basically the investigators. We're funded by NIHS and our P30 Center. And I also have some matching funds from the North Carolina Policy Collaboratory, which allowed me to hire like a science communicator and to collect some of the extra samples around Fayetteville. And so this is the one pager I made for NIHS. And I'm happy to take any questions.
Question. How easy or tough it was for you to go to people and ask them to get their used or tap water to be sampled?
Oh, they called me.
Okay.
So what we did, so one of the things, so we wanted to capture people at one point in time. There's a lot of community outrage. So I wanted to get like a cross section of people. And so being a little bit disorganized led to a randomization process. So people called us, we did a press release, we used our center's Facebook page, New Hanover County, all the partners' Facebook, call this number, and then we called people back. And so it was not a big deal. So we were scheduling people through the weekend, but to get volunteers, like people would call their neighbor or they'd convince their girlfriend that they'd call, make an appointment. So, and even in Fayetteville, we had people, so the rules were 4 people per household. And in Fayetteville, 2 families gave one child to another family so that they could get all 5 people in their house sampled. So people are really engaged. So, but partly then they expect me to share results with them. So when are we gonna get results? So I finally have I have tractor kind of analogies, because if you contaminate a mass spec with PFAS, you have to take it all apart and flush the system. So people who take apart machinery get that those kinds of things, as opposed to like the nitrogen generator is down. It's harder to explain that. But, and everything that we share with people, we have to send to an IRB. So it adds another level of complexity to that. But so we share, everybody gets their own results. And we have a public meeting to explain to the community. And when we released the blood results, we had one public meeting that we hosted. And then we held another meeting at the local NAACP meeting with a revival above us. And then we tried to host a meeting in Spanish, but in this day and age of ICE, it's hard to get Hispanic folks all in one place at one time. So, but we try to do that. And we're also working at creating some videos, share information with people, or digest things, because it's hard to get the reading level to an 8th or 9th grade level when you're talking about fluorochemicals. So, yeah, long answer here. Other?
I'm not sure. It looked to me like in your study where you had adults and children, the children had higher concentration?
The children had, I don't think I presented data separately for adults and kids. So
The gray was much higher.
Yeah,
I thought that was like how long that they lived there. No, that was how long that they lived in there.
I missed that.
But okay, but in general, so for the new chemicals, what we see is that the levels are kind of comparable for adults and kids, which makes sense for chemicals that have short half-lives. But the longer lived chemicals, the levels are much higher in the adults than the kids. So, so we're trying to get this paper together now. So we're like a 3-ring circus. We're like collecting samples, analyzing, trying to report back, trying to write papers, trying to get more money. And so, and we have EPA collaborators, which means we have to clear things at EPA. So we're hoping to submit that paper soon. And so it's interesting too that we do see that elevated PFOA in the kids as well as the adults. So it's not just an adult phenomenon. So kids probably are drinking higher levels. They come from moms who may have had higher exposure. So we don't know that piece so well. I still think it's the water for all the elevated legacy chemicals. It may not be from the chemical manufacturing plant. Because it'd be hard to argue that Fayetteville or Wilmington, North Carolina eats so much more microwave popcorn or something else that would make them off the scale for all these other chemicals. So I think it's still in the water, and I was talking to somebody earlier today, we don't know the bad actor for that. And so it's more difficult. Go ahead, there's all much.
Has the community or have you fully considered the implications of the urine emission and other industries?
So the Fayetteville Works plant is in the middle of nowhere. So there's not a lot of other industry like there. And Wilmington has a big tourist community. So there's not a lot of industry per se there. So I don't think so. And there's a lot going on. We are one small piece. So our partner Cape Fear River Watch, in partnership with the Southern Environmental Law Center, successfully sued Timor's had a consent decree that was formally signed in February of this year, which requires characterization of the full extent of the groundwater contamination, remediation of the groundwater contamination, providing whole house granular activated carbon water treatment systems for homes that exceed 140 parts per trillion, reverse osmosis for homes that are less than that, and like 99% reduction in air emissions, and other pieces too, but and the biggest environmental fine that North Carolina has ever. But of course, it goes into education, which is great, but they can't get a mask back for a DEQ. So there's a lot going on. So we try to keep on the science track and go. So I've spoken at the Waterkeepers Alliance meeting about that. Kemp, who's the river keeper for the Cape Fear River Watch, he and I went to the University of Michigan about a year ago and talked about our partnership. So we are really kind of connected, and there's a lot of sharing of information, but like everybody's kind of staying in their lane too, which is great, because I don't need to be in the fray. And all of our stuff says, this is your information, you can do with it whatever you want. And because we were funded, when we were funded by NIHS, our grant comes with a certificate of confidentiality, which means an extra layer of protection for our students. Because I fully expect to be sued, so. Which is a terrible way to start your research, but you might as well start out there.
Oh, yeah.
Yeah, so you mentioned that you collected residential histories.
Uh-huh.
I assume you mostly use those to determine if people live in the Cape Fear watershed for how long. But did you have any plans to use those data for anything further?
No. So one of the things we wanted to capture was within the Cape Fear Public Utility Authority, they have 90% of the people are on surface water and 10% are in groundwater. So what we also wanted to do was, were you served by surface or groundwater? And so we haven't really separated that out so much yet. And we stopped at 5 addresses because I realized how many places I had lived since 1980. And I was like, and that's a terrible thing. Like, make people fill that out. Don't collect it. Don't. So that, so that's really what we were trying to do, is so that we could separate out when you might have been a surface groundwater. We also got occupation, where you worked and where you went to school, so we can see where they fell as well. So we'll see. There's there.
Is there any, or has anyone analyzed concentrations in fish, or is there any plans?
So one of my colleagues, Scott Belcher, has a grant that's funded either by Seas Grant or our Water Research Institute on, he's looking at alligators and smallmouth bass in the Cape Fear. So one thing you should know is that the smallmouth bass, the Cape Fear River are infertile. They have to be, so something going on in that river. So they have to be populated. So Scott's got some funding looking at that, and his paper recently been submitted. So, so there is some interest in that, and our recently funded super fund is going to look at some of the trophic transfer issues of these chemicals as well. So the alligators have a lot of PFOS. So
They were measuring PPD levels in fish in Charleston, and in that case, they didn't have this.
right, and so I think that, you know, and for us, like, we just wanted to put the legacy so we could give some data to compare people to. We had no expectation that they were going to be so much higher, and so we don't know whether they wouldn't have looked like Parkersburg, West Virginia, because I did some back calculations and they don't get up to that high levels. But if the levels are really just decay, is what we're seeing. You know, they must have had much higher levels at some point. So we still need to figure out, are they at a steady state or are they coming down? So collecting some data in a couple years when we should, you know, we should be within like a half-life will be helpful for that. So there are many more questions than answered. And one of the things too, and I know that when you do community-based work, things that are super exciting to you are like really terrible for the community. Like we had our community science advisory board, and I was like, wow, look, we found Naphthalene byproduct 2 in everybody, and the room was silent. So have to be careful about your enthusiasm for, you know, like scientifically the questions are amazing, but these people are screwed, you know, and you have to remember that. I like that that is going to be recorded forever.
Yeah, so I noticed in your aerial photographs that there were some like isolated lakes or wetlands. And I was wondering if you had thought about using sediment cores to sort of reconstruct the airborne deposition, or if that would even be feasible.
I have not, that is something, crap, that's where the, what?
Genius.
Yeah. I think Jaeger on
Yeah, but it's so like, that's where like the, it's really boggy. Like, I'm sure you could do it. I mean, the only thing that grows there are Venus flytraps. So, and like pine trees. So, so it could be, and we have, and the people who live around the plant think that like their pine trees filter it, stuff. So good. There might be other things to know. Yeah.
Is there anybody looking at breast milk or, you know, like,
Who's got
pregnant
that?
women? I don't know.
Yeah,
I'm just saying.
so we didn't enroll, so we had like, you know, we were going minimal risk. So we didn't enroll pregnant women because we also wanted to get women at the same, you know, if you're going to get pregnant women, you have to get them the same level of pregnant. And if you're going to enroll them in a weekend, not going to happen. So we did have women offer like milk from their freezer. So we haven't looked at that. And I'm also interested in looking at whether we could analyze that in the newborn heel sticks, because that would be a good kind of long-term marker. So yeah, that's to be done. We haven't done that yet.
It's also near the coast, hurricanes. So I know that there was the hurricane
Florence.
years ago. Yeah.
Yep.
And it went up to water.
Yeah, just like my low-income participants got displaced.
What do you know, or I know there's other money available for disasters, but what do you know about their exposure post hurricane?
To
What happens
PFAS?
the water? Yeah.
To the PFAS, they just washed out to the ocean. You know, it wasn't, there was so much water going through the Cape Fear at that point. But what does happen now is that there are all sorts of like ponds, and just like the cement pads of the plant are like contaminated. So when you have all that water rushing out, but it just kept going. And actually it was pretty terrible because the water utility almost ran out of generating power. I mean, it was really terrible. Like, we pushed our report back a couple months because of the hurricanes, and people called us mad. I was like, you guys had a hurricane. So I don't think so. And we actually thought about pursuing a time-sensitive one to look at that, but we had too many moving parts at that time. And so pick what you're really interested in. Yeah?
Yes, so you really have a very big data set. So I'm wondering about the data sharing and management. So do you use any like public data repository to store your data and make it public available?
Well, I'm not going to share my data until I publish it.
Okay.
And most epidemiologists, I mean, we're not genetic, so I'm not planning to make it publicly available until we're done with it. I mean, that's part of our agreement with our participants. But we also are willing to have people collaborate with us. But it's a lot of work to collect data, and I want to be sure that our large team gets a chance to write the paper. So we do share information, but I feel like a little protective because we've done all the work to collect the data. And so we're happy to have people come work with us, but I don't think we're going to publicly share it for a while.
The question is about the GenX. So the relative short half-life, is that because it's being metabolized quickly?
It's not being metabolized at all. These chemicals are not metabolized in the body. So
it's being excreted quickly.
So, right. So they're probably excreted in the bile. Because there's like some complicated kind of protein binding liver in that.
Well, in one of the slides, what I did see here, your GenX is reducing concentration about 50%.
Yeah.
And other does not. What are the reasons behind on it? Do you have any ideas?
So why is the levels coming down? Yeah. The levels are coming down because the plant stopped releasing the chemical to the environment. And so they stopped discharge on about June 21st, 2017. And then took them a while to get all their, so in like by November, it was about 50 parts per trillion. And then 6 months later, about 10 parts per trillion. And that's because the source did a better job at controlling the discharge in the environment.
It is only for GenX, right?
Well, GenX and a lot of the other, so Napier byproduct 2, all the different discharge lines. So all of the things that were coming from the chemical plant were being controlled. Air emissions were about a year later, but now air emissions are about like 9%. Any more?
I just have one burning question.
Okay.
You kind of we talked about it a little bit at dinner last night, and I really enjoyed your talk today. But I guess you kind of mentioned, and as a scientist who studies smoking during pregnancy, I kind of get that same like excitement when I find out that the baby is born preterm or whatever, right?
Yeah.
And that's an issue. But with smoking, we can say stop smoking, which is almost impossible. But
right.
We can't really stop exposure. We don't really know what's happening health-wise to them, even if they have high levels. So how do you put the brakes on like the panic of a person that's like, oh man, mine's 10 times higher than yours?
So,
what does that mean? How do I control that, or what do I do?
Well, so the first thing
I'm going to probably steal your answer if it's better than mine when somebody freaks out and asks me like.
And if they don't like it, to blame me. So I think in general, knowledge is power. Right now, like they didn't have any information. And so they knew that they had been drinking that. And they still know that, but what's my number? And so, so that they can't change that. But I think for us to be able to show that levels are coming, even if we measure this in you, we know that levels are coming down. So one of the things that our community really wants is that they want better information for their healthcare providers on how to best follow them? Should they need some additional workup? Like smokers have additional workup. Can there be more? Like the people that I've spoken to have this kind of like, okay, well, we were exposed. We can't do anything about that, but we want to protect our health. So what kind of information can you help us create for our healthcare providers? And that, I think, is the way that, you know, and they're going to sue for, everybody's got their, yeah, I don't even know about lawsuits, but so the thing that people want to know, which is a weird thing. And even now that it's taken us, we also collected urine samples to see if we could detect the low molecular weight, and we just haven't been able to get those analyzed. And so people are calling, like, we want our number. And so I think that people are scared, but at least then they have some more information. And so some people, like, but in this report back, you know, if you have something that's weirdly high, you know, maybe it's weirdly high because, you know, like for something happened in the analysis that you couldn't figure out. But some people might be high and we don't know why that is. So, so I think in general, it's that knowledge is power, and that you can affect change. Like you can say, I've been exposed, look at what I had. And one of the things I think is big on our next list is to really do exposure reconstruction. Who's in the region that we need to figure out? And so, yeah, but I do think that people want to know, because then they can like act. So, terrible. Really.
I don't know this one. So.
No,
But you already have
hoping you had
reduced
the-
exposures by implementing, you know, reductions in discharges.
yeah.
I mean, and I think we can keep doing that. So.
Yeah, right. And so, but can you help the people who can't sell their property and can't eat the fruit and vegetables in the yard?
So Jane, wrapping it up. So Jane is a rock star. Let's give her thanks. As a plug, I forgot to mention she was just introduced elected into the Collegium Ramazini, which is a very prestigious international organization. Phenomenal rock star squad. If you want to get more engaged with what she's doing, she has postdoc positions open, so you can pass them along. She was phenomenal opportunity. So anyway, thank you. Encore, encore.